Then associate rule mining. Here is the associate rule mining for this. So it's the same steps like again and again, like I had to use it's kind of pre-built functions only, like I'm powering upon the different approach. Here I use some kind of different approach for this. Like here I read a pandas, matlodeep and the seaborn as these two are the visualization tools, and the PyCaret dataset it will get the data. And here I am using the groceries dataset.csv that I'll be reading, and from the pd read I'll load the data into the collapse. And dataset.head, these are the data available for me. And the transaction equals to dataset group by, so here I'll be grouping these two and apply the list to it. And once it's done, then the transaction encoder to convert the transaction data into one hot encoder format, then it will be performed in this. And the create a one hot encoder of the data frame. Now we can apply the appearer algorithm for this, appear algorithm like that I have uploaded here. So once it's done, then I have to check the frequency of it, like of what all the item sets and the how many things. I mean, bottle beer will be 0.15, bottle water is 0.21, and the beef will be 0.11, and the butter will be 1.26, etc. And the frequency dot item shape is 42 is to 2. And once it's done, then assuming frequency item to the pandas data frame, and we support it. Like here is the data for the plotting data for this. Like here are the data available, and the support wise, and the item selection wise the data sets. Here I'll import the PyCaret, and here I'll be performing the various other steps in a single go. Like I'll explain everything. Like I have read the PD data frames, and the transition data set is a group by, where I'll be performing the group by, and converting transfer into formats suitable for Apiro. And once Apiro is done, I have to apply that algorithm. Once it's done, then generate a association rule I have to generate here through the matrix of the confidence. And minimum threshold I gave is a 0.5, that might be depending upon the data set and other things. So here the I can display the frequency dot head and print dot head, that are rules. So for the plotting, these are the hex label, y label, the title for this. And this is the plot I get in the detail format way. And once it's done, then the scatter plot is done here. So for the same data, like the scatter plot will look like this. Like the more data is on 0.4 to 0.5, and the separate data are separated here, association root mining. And once it's done, here is a 3D plotting for the same tool. Like here is the exact view of the 3D plot, how it's done. X-axis, y-axis, and z-axis I have to deploy here. I have to show with the like photo the x-axis and the y-axis and the left and right. So everything I have to manually enter here, and post that it can perform the various other plotting graphs and tools. So yeah, associate rule mining is done. Then last two I left with the time series forecasting, that is univariant without exogenous variable, and univariate with the exogenous variables. So here is these two. And here the time series univariate without exogen, and this is a with exogen. So it's kind of a same process and same approach, where I'll be importing the full uh, PyCaret tools. And once I import the entire tool, like I'll load the data from my local to the collab, and I'll read with the pandas, and I'm importing the numpy as well. And here the data samples equals to true, and the train the data set and the test data set I have to separate here. And for training data set is 82,000, and for test one, like I have split around 2,000. And here train dot head, like this is my data will be looking as a train models. And once it's done, then PyCaret to get data, like here is another data set like which has and the PyCaret time series import, the setup has to be done here, and the description and the values is performed here. Like here seasonal percent will be true here. And this is the label for the from the PyCaret time series. And the plot model, the plot will be TS, like it will show the time series one, like from August to September, like for all the target variables and the subtotal of out of it. and this is the test data set, uh, train data set, how much accurately it's getting predicted. And here is the plot diagnostic of out of it, like histogram wise, total transmission wise, the diagnostic test wise, and the prediction wise, sample quality and other things, range active values and all. So once it's done, then I have to compare the model. So here is the comparing model. So out of, if you see, then auto armin is the best approach for this, and we can use that model. So for plotting here, the forecasting will be done here. So it's kind of a plotting where on the August 10th and August actual versus out of sample forecasting tools here. So this is the univariant with the exogenous variable. Then I'll be performing a univariant without exogenous variable. So here I need to import a pip install. Then once a pip install is done, then I have to read the data frames data set, that is I'm using the Delhi climate train and as a CSV file, and that I'll be importing from pandas, that I'll read it from pandas, and I'll import the numpy and the dataset equals to data dot dataset to convert the dataset columns into the datetime format, and setting up the index. Next, import necessary libraries from the PyCaret, and the third one is the set up the time series environment in the PyCaret tool. So this is the setup for that. Then the target variables I have to provide, and the folding variables as well. So here if I give all the variables, session period will be 365 days. So as and this is the time series data. So here is the one, like I got output for this, and the model will be Armenia. So it giving the best one. And the plot models is a model, like it's actually plotting from January 2013, July, Jan 14. It's going to year wise data from 13 to 14, 14 to 15, and the data goes on actual versus out of scope forecasting. So this is the main timestamp so of the predicted data. Once the data is done, so we need to predict the model. So for the predicting model, so here is the output for this, and here is the predict model, and the hidden period init equals to true, then it shows the lower, upper, and y part of it. Lower, as the return period int is true, then it just adds a lower and upper part of the data, like which are scattered there. Then I have to use a predict model. Here alpha will be 0.7 and it will perform the prediction. And for comparing models, like as I mentioned, Armia is the better one and accuracy wise. So that's the one. Here is a diagnostic of that, the mean timestamp and the histogram, and the range values and etc. So this is about the time series forecasting. Two are the time series forecasting, and everything is performed here. So these I'll be uploading in GitHub, and once it's done, this video will be in YouTube. Yeah, thank you. So this is the one, like I'll be explaining the part 2 in some other video. Thanks.